one is Joseph Spitzer from the University of Graz, and he's talking about limits to decompensation of greenhouse gas emissions through CDR sequestration in plants.
Okay, thank you. Okay, thank you. Let me just give you a short overview on what is underneath this title in terms of content. Negative emissions through carbon capture by forest is the first one. This will give the scope and the background of this paper, followed by 3 examples for this scope, and then I'm trying to come to some conclusions. Negative emissions through carbon capture by forest is characterized by a number of items that I'm showing to you. The latest, biggest one is what is said in the Paris Agreement 2015, suggesting to start establishing sinks and reservoirs, among other things, including forests. Negative emissions, and that is the title that is being used for that. The following conditions for storage in forests is to qualify as a negative emission. I have 3 items here. It must be an additionality compared to ongoing carbon processes. Second, the activities and the quantities have to be quantified. The project must be such that this quantification is possible for carbon accounting. And the third one, permanent storage at the end at least, is a prerequisite for qualifying as a negative emission. Just to give you an idea of what we are talking about, when we remove 2 gigatons of carbon from the atmosphere, this will result in a decrease of 1 ppm from the 400 that we are at this point. The conditions mentioned above can be fulfilled efficiently, mainly in existing and future what is called production forests. At this point, I have to mention that harvested wood products will not qualify for permanent storage. What is production forest? Approximately 10% of the total sea stored above and below ground in the global biosphere. 10% of this 800 to 900 gigatons are considered production forest. Okay, what are we talking about in terms of carbon pools and flows? We have the fossil pool, we have the atmosphere, we have the biospheric carbon, and as I already mentioned, part of that is production forest. And then we have something that is empty at this point, that is permanent storage area or volume. Fossil around 10,000 gigatons, atmosphere, biosphere about the same, slightly below 1,000. Energy per year, carbon emission 10 gigatons per year, and the permanent store is empty at this point. What we all are aware of, it's expected that the first filling process of the peak is the classical CCS from fossil fuel plants. So my question is related to what can be get out from the atmosphere into the biosphere and from there into the permanent storage. Example 1, increasing the terrestrial carbon stock. We're talking about the production forest part. Now, if we assume doubling that stock, that would compensate for 10 years of fossil fuel emissions. After those 10 years, you would have to further increase this terrestrial carbon stock. To achieve a permanent storage, once you have it in this stock, the material has to be integrated in commercial operations of existing production forests, which means this is resulting in an increased harvesting, replanting, which is costly, and hopefully compensated by a larger wood supply if you're able to put it into the market. So the possibilities for a continuing economically viable expansion of production forest areas seem to be quite limited. The example one here in graphical display, we have this doubling supposed to be possible, and then we fill this this doubled volume slowly with one annual emission. At the end, this will then be filled, and you have to think what we can afford after that. Second example, establishing dedicated biomass plantation. As the example is talking about sequestering 0.1 gigatons carbon per year, which is 1% of the current fossil emissions. This would require the annual harvest and permanent storage and replanting of 0.74 mega hectare with, for example, radiata pine plantation on a 30-year rotation basis. This will result in a total plantation area. Remember, we are talking about 1% of the emission to be sequestered. Total plantation area of 22 million hectares. That's about half of Sweden. And the required storage capacity is kind of open still. These would have to be established without affecting the existing pools and in forests and land use for food, feed, and material production. So the feasibility of permanent storage of carbon sequestered, e.g. by burying logs, you heard correctly, burying logs, is questionable from an economic or a logistical point of view. The path via biochar would perhaps be more viable, a viable option. This displayed on the graphic here, we have the annual input into the atmosphere here. We move 1% of that in the production forest, and from there it goes straight into the permanent storage. Remember, burying logs is being mentioned here. The option here is going the biochar route, which is perhaps technically and economically more viable, but still is not really a quantitative big step. Example 3, BECCS plants. I guess that's the most mentioned word in this conference, BECCS plants, using these plantation biomass that I was introducing on the example 2. The wood from plantation is used in BECCS plants instead of storing it. However, as long as we have fossil fuel plants in operation, it would be more efficient to equip the existing fossil fuel plants with large-scale CCS. Typically, the BECCS CCS sets are much smaller for various reasons, and to run the biomass plants independently in an optimized design. So both ends of a BECCS influence each other in a negative fashion, depending on each other. Furthermore, BECCS systems can be operated as NET only if their energy production can be competitively integrated in the energy market. So you might technically be able to build a BECCS plants, but then you have you need to sell the electricity under these conditions in the open energy market. Otherwise, it's not viable. Okay. Due to higher sea efficiency, energy output per CO2 sequestered, and economy of scale, fossil fuel or coal-fired CCS plants combined with optimized standard biomass plants have a higher potential than BECCS. The graphical display of that we have again what we have seen in example 2, the absorption from the atmosphere, and then you don't go straight to the permanent storage, but via the CCS option. Okay, I'm already in with my conclusions. The first conclusion is to qualify as negative emissions. Carbon storage by forests have to meet the following conditions: additionality, quantifiability, and permanent storage. Quantifiability seems to me has not received that much attention so far, but whatever is being established in these negative emissions has to be exactly quantified, because most of these actions will run under some kind of scheme that's comparable to carbon credits. And the people offering carbon credits under these circumstances have great interest in getting the bookkeeping correct. So it has to be quantifiable, whatever is ending up at the end in a permanent storage. Okay. The production forest, which is, you remember, the 10% of the total biomass on the globe, could possibly meet these three conditions. They are usually under some technical and organizational framework which allows to quantify this contrary to any other forest, for example, that is not in the production process. However, the doubling of this amount, so twice as many forestry type of operations that we have globally, if we add theoretically another if you double this, would compensate today's fossil emissions for only 10 years. So it's a limit there in terms of practical realization. The plantation option is has been shown in example 2. The sheer size of space of area required for sequester this this small amount here of 0.1 gigaton per year requires the set aside of half of Sweden's area. Doesn't seem quite realistic. So the final conclusion that I would be drawing myself from this is that CO2 sequestration by forest is a quite limited options for permanently removing the CO2 from the atmosphere. So just to add on, what else shall we do? There is no way around reducing the emissions rather than trying to build up a system of complicated and expensive negative absorptions, negative emissions. Okay, I have a acknowledgement to show to you from both my friends and colleagues and the Austrian Climate Change Center for helping to make this presentation.
Thank you very much.